Satellites are observing Earth 24/7, and historical imageries of the farm you manage are available from multiple satellite sources. This historical data could give you some specific insights about what happened and how it happened in the farm. Historical data could also be fed into artificial intelligence models to predict what will happen. Let's illustrate this with a wheat and canola farm in Saskatchewan, Canada. Knowing the coordinates of the farm, we queried its historical data from 2015 to 2020 whenever cloud coverage of the scene was less than 30%. We evaluated 3 indexes: Normalized Difference Vegetation Index or NDVI, Green Chlorophyll Index or GCI, and Normalized Difference Water Index or NDWI. A low value on NDVI means lack or poor vegetation. For GCI, it means plant stress, and for NDWI, it means water deficiency in the farm. We collected satellite data from May 15, 2015, just before summer started, and continued until the end of harvesting season in 2020, and plotted the historical vegetation index of the farm. Each data point in the graph is the average of NDVI of the farm for the date satellite image was taken. Next week. And next week. By the end of May, plants are emerging in some areas of the farm. Most of the farm is covered by plants canopy by early June. In late June, although most of the farm is doing well, vegetation is very poor in the marked area, with too much stress in plants. Water index shows this is not because of water deficiency. On the other hand, some spots of the farm show mild stress and delayed vegetation, which directly is the result of lack of water. 2 weeks later, situation is much improved. However, around late July, water deficiency significantly affected plants and reduced vegetation. This water deficiency was over by next week, and plants recovered fast. From there, it's the end of summer and harvesting is close. By mid-September, the farm is entering the winter mood. This season was just an example. Now, let's fast forward next 5 years and see how things fold out. This graph summarized performance of this farm over 6 years. However, it was a simplified approach that takes the average over the whole farm. The satellite data from the farm could be segmented into many subplots of desired size, and each subplot has its own performance history. Performances of subplots are not the same. Some show consistent under or overperformance compared to others. For example, here the subplot highlighted in green consistently overperformed the one highlighted in red. Here is another example. Each subplot could be as small as only 1 pixel of the satellite image, which corresponds to 10 meter by 10 meter area on farm scale. Each historical curve from each pixel or subplot indicates its future performance. Although such a data is overwhelming for the human mind, artificial intelligence models can digest and extract hidden patterns out of that. Knowing what happened in farm is not just about learning from history, but also predicting the future and taking a proactive approach. We feed historical values from satellite imagery and use artificial intelligence and time series analysis to predict performance of farms as a whole, or on subplots as small as a pixel size in satellite image. Let's get in touch and discuss how a combination of satellite remote sensing and artificial intelligence could benefit the farm you manage.